Hello, this is Jennifer Tassinger with A Plus College Ready, and hope you understand the mole concept by now because we're going to use it today in our calculations of empirical molecular formulas, percent composition, and hydrates. So here we go. Percent composition is percent by mass that can be calculated by using the mass of the element divided by the mass of the entire compound times 100 to get that percent by mass of that element or substance. So in the example that I have on the slide, it says, what is the percent composition of water? So I have to take my hydrogen, the molar mass or the atomic mass of hydrogen is 1.01 from the periodic table, remember, times 2 because we know water is H2O, and I have to multiply that to get the 2.02 grams of hydrogen in water. Then oxygen. I know from my periodic table is 15.99 or 16, depends upon which value you want to use, times 1, because there's only one oxygen in water, will give me, of course, the 15.99 grams of water. Molar mass of water is where you take the individual grams of each element, the hydrogen plus the oxygen, add them together to get my total molar mass of water of the 18.02 grams per mole of water. Now, if I want to know the percentage of hydrogen in water just by itself, I'll take the grams of the hydrogen divided by the molar mass of water times 100 to get 11.2%. If I want to find the percent of oxygen, I take my 15.99 grams of oxygen divided by the total molar mass of water of 18.02, then times 100 will give me 88.8%. Now, percent composition is easy because you can simply just add your two percentages together because those percentages should equal to 100. Now we'll pause the video at this time, go to your student notes so we can follow along for a couple of more examples. Now that you're back from the PowerPoint, we're here at the student notes on calculating percent composition for molar mass. Here's another example. C6H12O6, yes, glucose. And it wants to know what's the percentage of the total mass of carbon. Well, step 1, use the periodic table and the chemical formula to find the mass of the requested element. Use the chemical formula using the subscripts to find the number of atoms present in the molecule for the formula unit. So I know in this one molecule there are 6 carbons, 12 atoms of hydrogen, and 6 atoms of oxygen. Therefore, I have to, notice on step 4, now to step 5, and in order to determine the mass, i.e. 1 mole, I have to take those individual amounts of 6 moles of carbon, 12 moles of hydrogen, and 6 moles of oxygen, multiply it, get it, multiply it by its molar mass of each element. So I get my 12, my 1.01, and my 16 from the periodic table in step 3. I multiply each one of those values by the subscripts. Then to get 1 mole of glucose, C6H12O6, I have to add each one of those mole amounts together to get the entire molar mass of glucose compound in one molecule. Step 4, I'm then going to take just the part, aka my carbon mass, divide it by the molar mass, and I get my decimal amount. Well, to get your percentage, of course, we got to multiply by 100, and that will give you 39.97%. You can do the same for hydrogen and oxygen, and then check your percentages to add up to 100%. Now, obviously, if there's 3 elements, you can find the percentage of 2 of them, subtract the total of those 2 from 100 to get your third one. That's just a little shortcut if you want to. Now I'm going to pause the video and we're going to go back to our PowerPoint to go to empirical formula and then look through our examples. Now that you know how to calculate percent composition, we now apply that concept to what is empirical formula. Percent composition is given to you so that you can assume that you have 100% is also equal to 100 grams. Therefore, if they give you a percentage by mass of each element, you know that that is equal to the grams of each element. Well, empirical formula is simply finding the smallest ratio of the elements in a compound. And if it's an ionic compound, it's always the empirical formula is the true formula of that compound. So notice in our example on the PowerPoint, I give you the percent composition of sulfur oxide is 40.05% sulfur and 59.95% oxygen. Well, I know because there's 100 grams into 100%, I take my individual parts, my sulfur and my oxygen amount in the given, divide it by their individual atomic masses from the periodic table to get my moles of each element. Now what do? Well, I'm going to look at my least value, the smallest value, which is my sulfur. And I'm going to divide both of those by the 1.249 moles of sulfur. Therefore, my final answer, let me go back, will be 1 sulfur and 2 oxygens. So it'll be sulfur dioxide. Let's pause the video. Let's look at some more examples on our student notes. So let me walk you through some more examples of how to calculate empirical formulas. Again, empirical formula is the smallest mole ratio, whole mole ratio of the actual numbers present of the elements in the compound. So for covalently bonded molecules, you're always going to be finding the smallest. Take our glucose example earlier. The empirical formula for glucose is CH2O because 6 is the lowest common denominator. And again, as I mentioned earlier, an ionic compound, its empirical formula is the actual compound. Let me go through another example. Assume that you have a 100-gram sample always. You're going to convert your percentage to grams. So I have these percentages of sodium, sulfur, and oxygen. I know that's the same gram quantity. Then I'm going to take the gram quantity of each element that is given to me, and I'm going to divide it by the molar masses from the periodic table, the atomic mass of each element. I'm going to get my moles of each element. So if you notice, I've got 1.408 moles of sodium, 0.7063 moles of sulfur, and 2.812 moles of oxygen. Next step, I take my smallest mole value, use that as my common denominator, and find the ratio. So on step 4, this is what I've done. I've divided the mole value of each element by the smallest mole value to convert to a ratio. Notice I get 1.993, 1, and 3.9. Now, they have to be whole values. Remember, subscripts are whole values. So then I'll take my sodium of the 1.993, round it up to 2. Sulfur, obviously, is 1. And then oxygen will round up to be 4. Now, if you get fractional amounts, let's say you get a half of a decimal, like 1.5, well, that 1.5 value will have to be multiplied by 2. If you get a fractional amount of 1/4, which is like 2.25, you're going to have to multiply that by 4. Now, not just that element, but all of the elements. Once you find the rounded whole numbers of your subscripts, then you just put your elements in order according to their whole numbers. So that compound, of course, is Na2SO4, which is sodium sulfate. Now, we're going to be talking about molecular compounds. Let's stop the video, go to the PowerPoint, and we'll come back here for some more examples. Now that we're back to the PowerPoint version of our notes, you can pretty much stay here because they follow along our student notes until our hydrates, and that can be a separate video. Molecular formula, remember, an empirical formula is the lowest ratio of elements, but a molecular formula is an actual formula of a compound. So for an empirical may or may not be the same. As our example earlier, glucose was C6H12O6. Well, that 6 is actually a multiplier that we can find to use as a distributive property for our empirical formula of the CH2O to calculate glucose. And yes, that's what we're about to do. So here's your steps. We got to use this thing called stoichiometry. We're here. We're stoked about stoichiometry. you're going to need the molecular mass and the empirical formula. Now in the problem, they will give you the molecular mass, I promise you. Then you'll have to calculate the empirical formula mass. Basically, you're just adding another step to empirical formula. Once you find your empirical formula mass, that will always be your denominator. Your N value will be the multiplier in which you'll multiply your empirical formula by with using distributive properties to get your molecular formula. So let's look at an example. So what is the molecular formula of a compound that contains 40% carbon, 6.7% hydrogen, 53.3% oxygen? Notice the molar mass of this compound is 180.0 grams per mole, aka they gave you the molecular mass. So we always know from percent composition and from empirical formula that our percentages equal 100, therefore they equal 100 grams. So each percentage can be converted to its gram. It's the same amount. Then we'll take the grams of each element, use that dimensional analysis mole concept, go from grams to moles, divide each element, if you notice, by the atomic mass of that element. So carbon's 40.0 grams divided by 12.01 grams. That gave me my mole amount there for carbon. My 6.70 grams of hydrogen divided by 1.01 grams of hydrogen from the periodic table to get my 6.6336 moles of hydrogen. And then my 53.3 grams of oxygen divided by its atomic mass from the periodic table of 16.0 of oxygen to get my 3.3. Now notice, my smallest value now to find my empirical formula, my carbon and my oxygen are pretty much the same value, so you get the same answer of 1. So realistically, I only have to divide my hydrogen by one of those numbers. And I chose the carbon, of course, because it is smaller. Therefore, you see, the 6.6336 divided by 3.3305 to get 1.99. Now remember, this has to be a whole number to be a multiplier or a subscript of my ratio. So now that I've got my empirical formula, again, we're just adding a couple of more steps. I have my empirical formula of the CH2O. Now I have to take each element from my empirical formula, take that mole quantity of the subscript and multiply it. Remember, I'm going from moles to grams, and I'm going to calculate my molar mass of my empirical formula. So that is where I calculated the 30.03 grams of my CH2O, and I was able to use it as my denominator of the 30.03 grams per mole, and my numerator was given to me in the problem of 180.0 grams of my molecular mass. That gave me a value of 5.99, has to be a whole number, so I rounded it up to 6, and therefore I now found my multiplier, or multiplier if you will, of 6, and I can use distributive property of multiplying it to the carbon of 1, therefore I'll get 6 carbons, 12 hydrogens, and 6 oxygens for my final answer of glucose. Now, molecular formula is not hard, it's just very tedious, and you have to keep adding steps to it. So I hope you practice at this point, take some time, work through some problems. That's all you have to do is keep practicing. Now, our next video will be the continuation of this PowerPoint in our notes, which will be on hydrates. So good luck with your calculations of empirical formula, molecular formula, and percent composition, and we'll see you for the next video on hydrates. Good luck.